All right, so this is the homework problem you were assigned last night. The starting amount is 5 grams of calcium metal. Doesn't really matter whether you start with that part of the problem or start with balancing the equation or start with the molar mass calculations, as long as everything is there. But we do need to build an equation from this. We have calcium metal, and calcium metal is going to be what physical state? Solid. Okay. I know. If it doesn't settle down from the freezing thing in a minute, we'll just stop doing. I'll stop capturing for right now. Okay. And we have an excess of aluminum chloride. So that's AlCl3. I even gave you the formula. And it says it's dissolved in water. So what physical state will we assign to something that's dissolved in water? Aqueous. Okay. It says what mass of aluminum will be formed. Well, I don't have aluminum here. I have aluminum chloride. So by implication then, aluminum must be one of the products. Okay. What physical state would you assign to a metal like aluminum? Solid. All right. So what kind of reaction do you expect we'd have here? Single displacement. We need to know. Well, it is going to happen, or this wouldn't occur. But if you wanted to check, I had my test references out. Working with somebody yesterday, I moved them around. I don't know what I did with it. Well. So to find the solubility, this activity series, calcium is higher than aluminum, so calcium will displace aluminum in a compound. And so we're going to put calcium and chlorine together. If it's going to kick out the aluminum, then it's going to be joined up with what remains, and that's the chlorine. All right, so we have to balance this formula now, and we have to figure out its physical state. Calcium has a 2+ charge. If you didn't know that, where would you find it?
On the oxidation number sheet.
Yep, the oxidation number sheet, or the periodic table of oxidation numbers. And it shows you that calcium has a 2+ charge. What about the charge on the chlorine? 1 negative. Okay, and that's also on the same periodic table reference. So we need 2 chlorines to balance out the 2+ charge here, and that's going to give us CaCl2. Okay. Now we need to know its physical state, and for that, since we have an aqueous environment here, we need to look on the solubility rules. And on the solubility rules, it tells us that, rule number 2, chlorides are mostly soluble. There are exceptions for silver, lead, and mercury. And since calcium is not silver, lead, or mercury, it's not an exception, so this must be aqueous. If there's water around, soluble means it will be aqueous. Okay? So there's our unbalanced equation. To balance the equation, we're going...
It doesn't have to be in that order.
No. You can put this first and that second. Doesn't matter. You can switch these around over here. Doesn't matter. Okay? So, let's see. Let's list all our elements out here for an atom inventory. So we've got 1 calcium, we have 1 aluminum, we've got 3 chlorines, we've got 1 aluminum, 1 calcium, and 2 chlorines. If I have 3 chlorines on this side and 2 on this side, the easiest way to get it to be the same, and you don't have to do it that way, but the easiest way is to put a 2 here and a 3 here. Okay? So that changes the number of chlorines, but it also changes the number of aluminums on this side because I have both those in that formula. And it changes the number of calciums and chlorines on this side. So now we need to recount those. I now have 2 aluminums and 6 chlorines. And over here I have 3 calciums, and 6 chlorines. Let's see, now we need to get our calciums balanced because I just unbalanced it. Let's see, we need to put a 3 in front of the calcium. It's going to give us a calcium count of 3. And over here we need to put a 2 in front of the aluminum, and that will get the aluminum numbers to be the same. And so our equation is balanced. All right, so now we're ready to start with some calculations. Do you prefer to set up your calculation first or do the molar mass calculation first? Doesn't matter? Molar mass? Okay. Well, since we're starting with calcium metal, we're going to have to get it into moles. Now this is really, really easy because there's only one element here, only one atom in the formula for calcium. The definition of molar mass, okay, is the sum of all the atomic masses of all the atoms in the formula. Well, I've only got one atom in the formula, so the sum is just the one number. So we're going to look on the periodic table, the regular periodic table, find the atomic mass for calcium, 40.078. And that's going to be grams of calcium equals 1 mole of calcium. Now we're ready to do this conversion. All right, so we're going to take 5 grams of calcium and put it over 1. That's our starting amount. You put it over the number 1. Not 1 mole, not 1 liter, not 1 gram, the number 1. And we're going to use this equality statement, and you have to have an equality statement in this class in order to justify building a conversion unit. We want to match units and species in the top of this part of the problem with what we put down here in the bottom. So we're going to take this number with the same units, the matching units and species, 40.078 grams of calcium. So our units and species can't match. We're going to put the other side of the equality statement on the top. And we're going to cancel the units here and the species here. Just like canceling x's and y's in an algebra class. And we do the math. So we have 5.00. Multiplying by 1 and dividing by 1 just gives you the same answer, so there's no real reason to do that part. We're just going to simply divide by 40.078. And I get this really long number that we're going to have to round off. So this, in this problem, I've got 2 counting numbers. I'm not going to worry about those. I'm only going to worry about the measured and calculated numbers. This one has 3 and this one has 5. So we want to look at the one with the least digits and fix our final answer so it has the same number of digits as that least number of digits. So if this has 3 significant digits, the trailing zeros that follow a decimal place and a non-zero digit, those zeros are going to be significant. This leading zero is not significant, so our first significant digit is this one, 1, 2, 3. I'm going to underline from the 7 over. I need to include my units of measurement here and the species. And then we're going to round this off to 0.125 moles of calcium. All right. And that's the first step in the problem. The second step is to take this same amount here. And this is a new starting amount. So this is going to go over 1. Okay, just like we put this one over 1, we're going to put this one over 1 because it's a starting amount. At this point, we want to convert from the species calcium to the species we're trying to find. And the problem asks us what mass of aluminum will be formed. So we want to get to the species of aluminum. To get from one species to another, we use the coefficients in the balanced equation. So, yes?
Did you round 3 numbers instead of decimal because of the 0?
The 0 is not significant. Okay, yes. All right, so we want to match units and species in this part of the problem with what's down here. And so this 3 up here can represent 3 moles if we have all the coefficients represent moles. So we can say 3 moles of calcium and match the units and species here on the bottom. And then since we're trying to get to aluminum, then we want 2 moles for that coefficient of aluminum on the top. Cancel the units of measurement, cancel the species, and do the math. So 0.125 times 2, enter, divided by 3, enter, and we get 0.08333, and this is a continuing 3. It continues on and on and on and on. I could continue to put a bunch of 3's over there, but that line over that 3 means that's what we're doing, where it's a continuous 3. So this now is moles of aluminum. We need to have 3 significant digits again. Okay, so from here on over is going to be insignificant. Leading zeros are not significant. So we get 0.0833 moles of aluminum as the answer to that part of the problem. Okay? All right. Last step. That's step number 2. Now we're going to the last step. This is a new starting amount.
I didn't do the math.
Hmm?
You said we needed 3 instead
3 what?
of 3. You got 4.
No, the leading zeros are not significant. This is the first significant digit right here. All right. Hmm? So, again, we want the units and species on the bottom of this part of this fraction here, this conversion fraction, to match the units and species here. So whatever number I have here, it's going to have units of moles and the species of aluminum. If we're going to go from moles to mass, and that's what the problem is asking you to find, the mass of aluminum, we're going to do the same thing we did to go from mass to moles. It's a molar mass calculation. So we need a molar, an equality statement for that. Yeah. So for aluminum then, there's only one element here. There's not a lot of math to do here. We just look up the atomic mass of aluminum. It's okay. And so since I've only got one thing there, that's the grams of aluminum that equals 1 mole of aluminum. So the 1 goes right here on the bottom, and this mass number goes on the top. I'm going to cancel units and species that we can cancel, and we successfully have gotten our problem to the point of finding the mass. Grams is a measurement of mass. So I'm going to plug that in now. So 0.0833 times 26.981538, 2.247 562 1154 grams of aluminum. 3 significant digits are needed. Got 3 here because leading zeros are not significant. Need 3 digits here, so we start underlining from here. The 7 makes the 4 round up to a 5, so we get 2.25 grams of aluminum. And just to double check, we're looking for the mass of aluminum that's formed. That's the mass of aluminum that's formed. Any questions? All right.